In this demo, we'll connect a 5-volt geared stepper motor and get it to rotate. Because this motor has gears, we need to take into account the external/internal shaft ratio when we are directing it to execute a step. The schematic looks exactly the same as in demo 1. So what we're going to do now is replace the original 12-volt ungeared stepper motor with this one, which is a geared 5-volt motor. So 5-volt DC. It's just a drop-in replacement, really. Now, looking at the sketch, again we're using the same stepper library as earlier. Now we've got to define two things. The first one is the number of steps required for a full revolution of the motor itself, where the second one down here is the number of steps required for a revolution of the external shaft. So this one is the external. Now this motor here has got a 1:64 ratio, so internal to external. So what I've got is that I need to the external shaft is going to require 64 steps for each of the internal 32 steps in order to complete a full output or a full revolution. And once I do that, I define the stepper object. I pass a number of steps for full revolution of the internal motor, where it's connected. Then, nothing to do in setup. In this case, I go into loop and first set speed, just like we did earlier. Then I'm just asking the motor to take a bunch of steps. I want to take this many steps, so it's going to be 64 times 32. Define that up here. Now to complete a full outer revolution, so revolution of the outer shaft. Once it's done, I wait for a second, and then do the exact same thing, but in the opposite direction. So plug that in and upload the sketch. There's one revolution, and going back the opposite way for another revolution. Now, one thing that I can see is that if I try and stop the motor with hand, okay, I can now, it's now almost stopped, but the torque is much higher for this motor, even though electrically it's a smaller motor than a 12-volt motor we saw in the first and the second demo. So it's the gears inside the box actually multiply the torque, so this can move higher loads even though it's a smaller motor. You can also try to tweak these numbers here. So maximum speed, I've got 500 down here, make that maybe 800, and see the effect it's going to have. So that's the 800. I can feel by holding it that it is skipping a few steps. It's not moving from one step to the next as smoothly as it is now, so it's a bit slower.